Alright, you guys, as the last example in the last video suggested, right, domain is really important. We got to make sure that not only is my original function defined, but whatever value it passes on, we also have to make sure that that's still defined. So let me kind of show you a picture, a schematic, what's happening. So when we have f composed with g of x, which again is written like that, not only do I have to make sure that the original function that I start off with is defined, whatever value it passes on to f, I need to make sure that that is defined as well, not to mention that the overall function that we build is fine. So basically what happens is we need to first, right, I guess if you want to, step one is to look at the domain of the, how about I call it the inside function. Right? So what function are we putting inside of the other function? So in this case, I'd have to take a strong look at what's my domain of g of x. All right? And then step two, what you want to do is to perform the composition and make sure you simplify as much as possible. And then step three is you want to find the domain of the composition that you created, the new function. And then step four is we pretty much, right, we build the overall domain from these two steps. So if you're following along, I'm going to have two domains, right? So the domain of the inside function, the domain of the composition, and then we're going to put those two together, right, and build the composition of the composition all together. All right, so we have to make sure we're defined, and then I have to make sure that what I've passed on is still defined, and then we piece it together. So there's basically your step-by-step process in finding the domain of a function. So looking at our first example, we're eventually going to find f composed with g. So we are in fact putting g inside of x. So I got to first figure out, well, are there any red flags for the beginning function? And there are, right? So in this case, we have to make sure that the x minus 1 is greater than 0. So we basically have to make sure that we're greater than or equal to 1. And so for this function, when I put this in here, right, we're looking at f of the square root of x minus 1, which is 2 square root of x minus 1 plus 5. So there's our composition function, and it turns out that the domain for this one is still limited by that guy right there. So it's still, we're going to have to make sure that we're bigger than 1. So putting these two guys together, they essentially coincide with each other. So what's our overall domain? Well, we have to make sure that our x is greater than or equal to 1. Of course, in interval notation, we're talking about 1 to infinity. So there is how we kind of piece that story together. So find the function of what we're putting inside, perform the composition and simplify. There was really no simplification to do, and then find the composition of what's left over. And the only red flag is the same red flag that we started with. So basically we started with a red flag, we ended with a red flag, and so that's where we're at. So for the next one, again, we're considering f composed with g. So we're going to be looking at f of g of x, which is f of 4 over x. So what's my domain problem at the beginning? Well, x cannot be equal to 0, right? So that's one of the first things, right? That's the domain of the inside function. X cannot be 0. So when I evaluate this, we're putting this inside of here. We get 4 over x and 4 over x plus 3. As we saw before, to simplify this, I'll multiply upstairs and downstairs by x, and this gives us 4 all over 4 plus 3x. So there's the composition. Of course, now that we've got the composition, what's the domain of it? Well, it also has a division by 0 problem. So solving that, we get 3x can't equal negative 4. Dividing by 3, we get that x can't be equal to negative 4/3. So x can't be equal to 0. X can't be equal to negative 4/3. If I put that on a number line, right, we're throwing 0 out and negative 4/3 we're throwing out. So putting it together, it looks like we're in this part, we're in this part, and we're in that part. So in interval notation, we're talking negative infinity to negative 4/3, union negative 4/3 to 0, union 0 to infinity. So there would be our composition domain by building it in pieces, right? Finding the domain of what's inside, finding the domain of the result of the composition, piecing it all together to find the domain of the entire composition. So I got to make sure whatever I put inside is defined, and I got to make sure whatever's the output is also defined. Okay? So what about the next one? Well, again, we're putting g of x into f. So we're putting x squared into f. This guy doesn't have any problems whatsoever. Strong function. No issues with g of x. And then when I put it inside the function, what we get is x squared plus 4. So I basically have to make sure that my x squared plus 4 is greater than 0. And if we think about this graphically, this is always positive, and this is always positive. As a matter of fact, the graph, right, is a shift of x squared 4 units up. So this is always greater than 0. So this also doesn't have a problem. So putting these two together, right, the domain for everybody is everybody, right? That was everybody going in. It's still everybody going out. So it's everybody coming all together. All right, so we're off to the races. Okay, and then of course, how about I do this one just to be, what if we flip this around? G composed of f of x. All right, well this time, right, we're starting with the input of f of x. So what's my limitations? Well, x has to be greater than or equal to 4. So there's our initial limitation. When I put g inside of here, we're talking about this. And that's basically the square root of x plus 4 squared, which is x plus 4. And this guy, right, so we've done the domain, or excuse me, we've done the composition. What's the domain of that? Well, that's a line, right? And so this is everybody. So if we put these two together, my initial function has a problem, my last function doesn't, but we're restricted by that guy there. So if we put these together, my domain restriction is that. So negative and 4 to infinity. So even though the resulting composition didn't have a problem, right, the fact that the inside function did pretty much restricts it for everybody. So we have to make sure that we're restricted from negative 4 to infinity. So that would be the other way around if we flipped it. And again, showing, you can't assume that your compositions are the same, because even the domains aren't the same. Alrighty, so there you have it. There's your domains. We've got one more topic to talk about, and I'll do that in the next video coming soon.